Retrieval augmented generation, or RAG, is often treated like a search out of the box. You take your data, you slap some embeddings on top of it, and you just run user queries against it. But in reality, you need much more than that. You need systems, you need metrics, you need processes that actually allow you to get a quantitatively good RAG system. So, how can we get to that? Today, we are talking to Saahil Ognawala, the head of product of Jina AI, and we talk about the systems and processes necessary to build RAG systems and how synthetic data can help. Welcome back to How AI is Built. Let's jump right in.
Synthetic data is something we also tried. For us, the task was much more important than the persona itself because we were trying to create this instruction-tuned embedding model. So we dropped the persona topic altogether. But I can totally imagine that for language generation specifically, adding personas would add another dimension. Could be quite useful.
What dimensions did you guys use?
So we had this, I'm not sure if you read this E5 paper. It was a very popular paper, right? The E5 Mistral Instructor Embeddings paper. And basically the entire idea of fine tuning with synthetically generated data, at least in Gina, started when this model was released and we got into understanding like what makes this model good and so on. And of course, the main proposition of this paper was that you can train a great embedding model by just using synthetic data as a proxy for distillation method. So you would generate high quality synthetic data using what is a good quality LLM as well, which in that case was GPT-4. And then you would fine tune a Mistral model using the synthetic data and basically just treat it as a decoder only model instead of just an embedding model. Right. And in this paper, they only use synthetic data. I think it was in the order of tens of thousands, if I'm not wrong. And what they introduced was this nice idea of like conditioning based on task type. So the authors of the paper, they wrote a few templates of what types of tasks were they interested in to solve with this embedding model, but not in addition to this category, they didn't tell it anything else. For example, if the type of task is classification, they didn't tell it that you might use the embedding model to classify documents of one kind versus another kind, or you could use it to classify sentiments from one kind to the another kind, right? So they would set a task template, but within these task template, they brainstorm together with the LLM what topics or what specific tasks can you do with the LLM, with this downstream train embedding model. And then in the next step, you would condition the data generation based on this task that the LLM itself generates. So it's like a very nice way of constraining what the LLM produces, but within those constraints, be like very diverse and as creative as you want, which is like really the trick to synthetic data generation.
I think the movement is really interesting. We started out basically with rule-based systems. We moved into training with data, and now we are basically moving into generating the data we want, so we can train the AI to do what we want.
Yeah, and the leap has also been quite extraordinary. I remember when I was not working for Gina, but I was working for a company where we were using structured data for classification. Generating synthetic data was still a topic back then, even when LLMs were not around, right? But then it was always a given that one side to this argument would always be, okay, if you can have a system that can engineer synthetic data, it would be not trivial, but close to being possible to also reverse engineer the system to just learn the rules, right? So why wouldn't you do that? And just the leap from that point of thought to today, where you say that, okay, of course you should use synthetic data because none of the intrinsic models that you would have for your business would have close to the world knowledge that an LLM would have. So it's futile to discuss whether you can reverse engineer it to the rules that you use to generate synthetic data.
Yeah, I think the general capabilities are necessary that we can move beyond the behavioral cloning, that we just have a fixed set of rules which are ingrained in the data and the model is actually learning them.
Yeah, correct. That is still to say that we don't know what rules are in coded LLMs. It's just that we know that the volume of those rules is so high that it's very likely that your synthetic data rule, which is somehow implicit in the business, is also encoded in there. So it makes sense to use it. So yeah, I agree completely that this leap is something that you simply cannot ignore right now. All you can do is like closely control it, in my opinion.
Yeah. What do you think can we take away or learn from the previous eras, the more traditional rule-based systems and rule-based retrieval systems?
The main thing, in my opinion, is still that you need to have control over what your end goal with these retrieval systems is, right? Ultimately, everything that we talk about is revolving around understanding what is the intent of the user, right? If you know what the user was intending to do with your search system or intending to do with the results that you get out of this retrieval system, there would be no better proxy to this than saying that, okay, I know what the user is going to do with these search results and then what they're going to do downstream with it. That's why I should show them a certain set of results at first. Everything that we do is put a proxy on this intent understanding, which is what we did 20 years ago. 20 years ago, I was not working in the field. I was still a student, but I imagine that's what the seasoned professionals in retrieval still did 20 years ago. And I truly think this is still something that we're doing today. Like understanding the intent of the user, much more different than creating rules about how should you rank results or what kind of learn to rank algorithm you would use. And that goes again into what you said about these persona creation synthetically, right? One of the main reasons why the persona creation with synthetic data is so powerful is because if you create enough personas, you also create enough implicit intents behind why someone would use a retrieval system, right? And this certainly has not gone away from the traditional systems to now as well.
Yeah. Do you think this part of actually trying to understand the user intent is a little bit lost at the moment in especially like the RAG space? Because
Yeah.
everyone is just basically trying to slap embeddings on it and using it like as a cure-all.
hmm I wouldn't know if I could make a judgment one way or the other whether we're focusing on it enough or not enough, because ultimately I don't think there is a way to understand the intent of the user directly unless the user directly tells you something. And what LLMs and RAG especially allows you to do is it at least offers an opportunity to the user to lay this out very explicitly, that I'm going to attend a ceremony, a wedding ceremony of my close friend. I need to stand out in the crowd, show me ties and matching shoes that make me stand out in this occasion while I being like seasonally appropriate and all that. All of this was simply not possible to do with traditional token based or just keyword based search systems, right? So at least we're trying to get close to that. I have to say that there is also the inherent risk that the user itself bias themselves too closely to what they think works for a rack system with instead of maintaining the fidelity to what they actually want. So that risk is obviously there. So yeah, that's the most I could say about it. That RAG allows you to express this in a better way. But if you're only using a naive RAG technique to then translate it to something that your product catalog can understand, that is a part that we're all trying to get better at. I don't know.
Yeah.
I would also be interested in understanding, like, why did you ask this question? Like, where have you seen this pattern where you say that the understanding of the user's intent is something that we completely lost sight of?
I think also in LLMs, most people or like the field always starts out very raw, trying to invent something completely new, and then over time they converge again to like
Mm,
how we've done it previously.
yeah,
And this basically means being very metric driven, very methodical, setting up evaluation data sets and trying to iteratively improve the system over time
yeah.
based on metrics. And I think at the moment in the LLM space, we are already doing that loop back, that we're starting to set up like evaluation data sets. I think in RAG, that's
hmm
still a little bit lost. It's still a little bit
I
missing.
see. I see. Yeah. I would agree there with you as well, especially people who are setting up RAG for the first time or are doing this as a replacement to traditional search engines. I think there is a certain lack of missed messaging, perhaps, that none of this language generation will help you move away from the fact that you need to set up your own retrieval benchmarks, which is specific to your business use case. You need to have an expert look at these retrieval benchmarks as well and continuously update them based on whether the needs of the business has changed, whether the system that you have put in place showed behavior that you were actually not interested in. deriving from it. And it isn't a magic wand that you can just like place on your catalog and expect results that you didn't expect before, that you didn't get before.
Yeah, I think like for me, search is not like an AI practice, but rather like an engineering practice.
Yeah.
It's very methodical. You have to follow like a practice. You have to follow like what the data tells you in the end.
Yeah.
And it's more about a frame of mind, how you approach it, rather than who does it.
Yeah, absolutely correct. And this frame of mind is not something that you can replace with an AI, unfortunately, not right now anyway. This frame of mind is something that is also cultivated in a way in the minds of an expert who's experienced with retrieval, who knows what metrics to tune, as you said, right? This is not something that you can replace with an LLM entirely. That's why I also say the most interesting part in even synthetic data generation, either for evaluating RAG or for fine-tuning embedding models, for example, the most interesting part is not in whether you can generate data that you wish you had, but you simply don't have because real users don't interact with your system in that way. But the real interesting part is actually constraining it within what your system is supposed to do and let it be as creative within those limits as you can. That's really like the needle in the haystack, if you will.
Yeah. Would you say makes for a bad evaluation data set for RAG or retrieval in general?
Okay, I want to start with what makes it an acceptable data set at all. And it would become clear why I start with this when I get to what makes it bad. Because one of the things that is overly missed typically in these retrieval benchmarks is a definition of what is a bad result, right? And I'll tell you what a typical retrieval benchmark, evaluation benchmark would look like. You would have a question and you would have an answer. In case of traditional search system, this answer was like a document ID or a product ID or a product title that you should be retrieving given a user's search string, right? In RAG, you can think of this as a user's query in natural language and the answer as being an answer generated by an LLM, also in natural language, right? The right answer. What is equally important, in my opinion, is having some bad examples of what an LLM can give you. And this is what makes it a bad retrieval data set if you don't have the examples where you say explicitly that this would be a bad result if my RAG was to spit this out. Hallucination is, of course, one part of this, but if you can't tell in real-time usage whether an answer is a bad answer or a right answer because the LLM just makes it look like the right answer, then you only have your retrieval data set to blame for this, in my opinion. Hallucination is like a special case of this bad answer, and an example of this could be like you could be having a chatbot for insurance policies, for example. If you have a chatbot that answers questions regarding insurance policies, the whole idea behind this chatbot, at least I imagine this would be the whole idea, would be that these policies are so complex that a layman who just wants to cover their assets over the course of a year is not interested in going down to the deep specific of what each clause says, right? And you would then have this chatbot explaining to this person who's your customer, hopefully, what is an answer to a question like, okay, if I get sick abroad, which hospitals am I allowed to visit? Which hospitals are covered by this travel insurance policy, travel health insurance policy? What you would expect the RAG system to give you is an answer grounded in facts, of course, but of course, an LLM can generate an answer that looks like it's based in facts. It's based in any clause of the policy, and the user would simply not know any better. And then it is actually the task of your retrieval benchmark to say that okay, even though clause one and clause two both sound similar, and even though they're both answering the question related to what are the overseas travel policies related to when you get sick, this answer is more correct than this answer, or this answer is actually not correct at all because it doesn't specifically say what kind of hospitals can you visit. Just as an example. To close the circle on the question that you said, one of the bad practices, in my opinion, to what would form a bad evaluation benchmark is when you wouldn't have specific examples on what forms for a bad answer.
Yeah. Do you typically set up basically end-to-end evaluation data sets and then a data set only to evaluate the retrieval system as well?
Typically, you would do both of those things, obviously, but typically what our customers do is use some ready-made frameworks that allow them to set this evaluation framework up. And these ready-made setups like Ragas, for example, or Quotient AI, they have a lot of inbuilt metrics that they, even though all they ask from the user is the pair of question, answer, and retrieve context. And the idea is the following. Basically, what you want to check is whether the context that you're giving to the LLM is the right context given the question, right? So if you have a user's question, you want to retrieve the passages from this insurance policy document that I talked about, right? You want to retrieve the right passage that are relevant for answering this question. And these tools measure whether you are actually retrieving the right context. But then you also want to measure whether the generated answer from the LLM is following this context. So these are the two key metrics that you should always track. One is the precision of the context, so the context precision, and the recall of the context. And this recall is actually reflected in the answer that the LLM generates. So usually you would actually benefit a lot from having a human generated answer for a user query, because then it makes it easier for these automated frameworks to see how similar is this user generated answer to an answer that the LLM creates. This is one. And then finally, there's also this idea of faithfulness in the answer generated by the LLM. And faithfulness is nothing but it's a very crude metric in my opinion, but it works. It's basically saying that from the amount of answer that the LLM has generated, how much of it is relevant to the question and relevant to the context that you provide, and how much of it is fact, but there is no way to check it. So if you're asking about a policy document and the LLM is giving you answers about your Hausratsversicherung, how's it called in English, or a legal policy document, legal protection policy document instead of a travel insurance policy document, it is right that you have some kind of legal protection when you might be abroad, but it's simply not relevant to the user's question. So that's the concept of faithfulness, which is like the proportion of how much of the answer is relevant to the context and the user's query versus how much of the answer is there, might be right, but it's simply not checkable. You just can't check whether it's right or not.
Yeah. And if you like put your consultant hat on even further, if you come into a new company which has a rack system but no evaluations, like
Yeah.
what are like the steps you typically would go through to basically build an evaluation data set for the rack?
Mm-hmm. Yeah. The first thing I would do is find out if this company has any experience with building a search and retrieval systems at all. Because if it has any experience in doing so, then it would be clear very soon to them, even before LLMs came into the picture, that you need to set up some kind of an evaluation framework for this retrieval system. And these evaluation benchmarks for simple retrieval systems are honestly like worth their weight in gold. They don't weigh anything, but they're golden. So that would be the first place to start. How would you turn these existing benchmarks into something that would be understandable as a user of a rack system? Let's say, how would you convert the nature of the queries that you're seeing on these retrieval system to natural language queries, if that's what you're expecting your rack system to answer? And the same thing for the retrieval for the retrieved answers as well. So that's number one. I would take this existing trove of information that has already been used before to create some kind of retrieval system. The next thing I would do is to set a baseline for evaluation. You need to find a way, or you need to have a way. Ideally, it's always the way that is easiest to implement, has well-grounded and well-researched reasons for why these results are computed in a certain way, and typically it would just be BM25. So I would set a baseline up with BM25 retrieval, which tells you, given a question, whether you're retrieving the right answers using just BM25. And that is your minimum, right? If you cannot do better than BM25 by introducing semantic concepts to your retrieval system, then why would you even do it? The next step on this would be to understand like the business context around it. Typically, a company that is looking to move into RAG from having only a traditional retrieval system in place, typically they would have on top of GM25 some kind of business specific re-ranking logic, right? And I would try to encode this business specific re-ranking logic into either an LLM or a business specific, maybe fine-tuned even re-ranker. Because these re-ranking logics, again, is something that traditional BM25 engines would not be able to encode, because they're only based on keywords, synonyms, and symbols in your search, basically syntactic. So this is something that I would do as well. And in terms of setting up a RAG end-to-end that includes semantic context. That's when it comes to evaluation of different embedding models for retrieval, because without having a close control on whether your context that you're retrieving to give to the LLM is correct or not, I don't think it's worth creating an entire end-to-end pipeline at all. And I especially don't think it's worth evaluating which LLM is best for your use case if you can't get a handle on whether you're retrieving the right context or not. And once this is done, only then one would go into evaluating what LLM would be best fit for the use case. What would be the criteria for determining whether you should, for example, fine tune the embedding model? You simply shouldn't fine tune the LLM, which is something that I would just put at the onset that usually if you're just setting it up for the first time, you simply shouldn't fine tune the LLM. Fine tuning an embedding model is a good question, and figuring out what are the choke points at which an embedding model doesn't perform well for your business use case, and then setting those up again as an additional baseline for seeing whether fine tuning would make sense would be then the final step for me.
Yeah, and especially I think like before you move into fine tuning, you should have a good evaluation data set and also an automated setup that runs basically your new retrieval pipeline with all its new components end to end and evaluates the different components and the end to end performance.
Absolutely agreed. And internally at China, we have this unsaid rule, which is not in any policy document that we have, or not like any of the usage policy document. But whenever we get requests from our enterprise users asking whether we can fine tune a model on their business use case, our one rule is that they have to have used up at least 1 or 2 billion tokens either on our APIs for embeddings or on their own self-hosted system for it to make sense for us, because it's not about the tokens that they've used, but really it's about understanding whether they have used a general purpose embedding model enough to even come to the conclusion that maybe we should try out fine tuning as an antidote to not having enough precision in your context.
Yeah. And what I'm really interested in, especially in the data set for fine tuning embedding these models as well, is like the concept of negative and positive examples for retrieval. And these, especially like for fine tuning, are very interesting because you can do more interesting losses for the fine tuning, especially like contrastive loss, which boosts the performance. Can you maybe explain like what are negative and positive examples, and also how are they created?
So that's an important question for embedding models, because the common knowledge in this field right now is that you want your loss function to decrease the distance between the user's question and its right answer and increase the distance between it and the wrong answer. And what makes it even more interesting is this notion of hard negatives. And the idea of hard negatives is that they sound like right answers, but are actually wrong answers, because they simply convey the wrong information to the right answer, to the right question, even though they might have a lot of same words or same structure. For example, if your user is asking for a gluten-free chocolate cake recipe, and one of the answers is a flourless chocolate tart, this is close to the right answer. This is what we call positive. Whereas another recipe, which is called sugarless chocolate cake or sugar-free chocolate cake, it might sound like the right answer because it has a lot of the same words as the question, but it's not the right answer. So you shouldn't give it as an output. And what you want to do during your data preparation time is use something like a cross encoder model to get a lot of the similar sounding in structure and tokens answered from your question answer data set. And you mark most of them as hard negative for a question, except for the one answer which you know is the right answer. This would be one way of doing this hard negative mining for fine tuning or post training your embedding model, so that your model learns to put the hard negatives or these right sounding wrong answers far away from the question.
Yeah, I think for hard negative, the best example that always pops into my mind is like the Paris versus Paris Hilton example when you do like regular term search.
Yeah.
That you, depending on the application, if you have like a music application or like a fashion one, you rather want like the Paris Hilton one to pop up.
Right.
If you have a more geographical Google search query, might be probably that it's the city.
Yeah, correct. Even though both Paris and Paris Hilton have 50% similar tokens. You want to make sense of these terms in the context of the question that you're having. And that's what setting the right contrastive loss with positive and negative examples does essentially.
Yeah. And it's actually very hard to really, for one, get people to say what should this query result in, and which like results are really like the negative and hard negative examples. Unless you really spend some time building those data
Correct.
sets, you don't really realize how hard it is and how hard it is to actually codify it in some kind of way in a document, or just
Right.
like basically tell people like, what are you looking for?
Absolutely. And if it wasn't this hard, you would expect that a purely semantic engine that takes, I don't know, cosine distances between the query and the answer or two sentences on, you would imagine that it would see enough information out there that is non-correlated that it would simply learn this distance by itself. The fact that it is hard is reflected in this fact that the hard negatives and the queries actually do appear together in the real world data a lot, that you have to manually label them to separate them together.
Yeah. And this is actually like for the model to know what is the user's or your user's intent, it's impossible. So you
Yeah.
have to set it.
Okay.
How does synthetic data actually come into play here? Can it be used to basically generate all of the data set, like positive, negative, hard negative examples?
Yeah. So in our experience, yes, actually we have an automated pipeline to do this as well. Again, I refer back to the E5 paper of Microsoft where they had this interesting idea of conditioning LLM outputs on diverse topics generated within some constraints. And what we found is that you can extend this idea of conditioning LLM outputs by also including different data types and including different data formats that you want generated. So essentially, in the so-called task template that Microsoft authors use, they use different task templates like classification or clustering or retrieval. What you want to add to that is also something like misguided examples or negative examples for a query. And using this, you can actually force the synthetic data generation part. So essentially, any LLM worth its salt to generate hard to distinguish examples for the same question. So you can ask it again a question about geography of France and have two different answers to it. And in fact, the hard negative it's much better to condition the hard negative on the positive answer in this case, instead of only conditioning on the query, because that makes sure that you have some examples that are counterintuitive to what the current correct answer should be. And that's what you should label essentially as a hard negative. So synthetic data generation in this sense can be very useful to get a large volume of hard negatives, because typically in fine tuning stages, finding the right balance between how much hard negative data you need, how much triplet generation you need compared to how much pair data set do you have for contrastive learning is actually the tricky part. And as with everything else, my suggestion is that synthetic data should be used not as a replacement for expert decision, but actually as a factor that can inflate the amount of volume that you have of negative. I would still recommend having complete control over what the hard negative topic should be. For example, where should it sample these topics from a dictionary, a multilingual dictionary, if you may. But when it comes to conditioning them on a few examples from the past, the best results appear when you do use few shot learning in this case rather than zero shot learning. So you do give the LLM a few examples of what a question, a good answer, and a bad answer to this question looks like. Then condition them on a diverse set of topics from dictionary and let it generate hard negatives based on the query, the diverse topic, as well as the true negative or the true positive, so to say.
Yeah, I think the concept is it's I think the concept of like synthetically generating hard negative, it's like a little bit hard to grasp because you're
Yeah.
trying to find something that's semantically very similar but conceptually different.
Correct.
And do you maybe have an example of a past project you've done which makes it a little bit more like graspable?
We had this project. So when we were trying to publish a paper in ICLR to add to this E5 paper of Microsoft, we tried to generate a few hard negative examples to show whether the fine tuning makes sense or not. And one of the examples that we had was something to do with ocean life, marine life, right? And the idea was that the topic that we were interested in generating was related to marine biology, the questions were all related to what scientific classification does this kind of a whale have? And then you have some answers to it. And some of the answer, if you didn't condition it exactly on the topic of marine biology, the LLM would go into generating answers that are related to marine engineering, saying things like, okay, this instrument is widely used by marine engineers to measure depths in oceans and so on. It has everything to do with marine biology, but nothing to do with the question that I asked it about whales. And without conditioning it on the true positive or the right answer, it would go on blathering about all of these unrelated marine engineering topics, which would not semantically, obviously, because a human eye can tell that this is semantically not relevant to the question, but at least from a mathematical point of view, you would get a close enough cosine similarity or some kind of similarity with this, but only without conditioning. But when you start conditioning it on the true positive, it starts generating answers about fishes and whales, which you wouldn't if you wouldn't condition it. Uh, you can imagine that marine biology is closely related to biology and a lot of research fields. So there would be a lot of terminology that would co-occur, but not exactly the ones that were related to the question that the user was asking. I don't know if this is an interesting answer for your readers, and I'm happy to find more in the question draft, in the paper draft as well. But just something that stuck out to me, at least as one of the
Yeah.
error cases that we were trying to deal with.
No, I like it. I like the examples like from practice. I think like stuff in marine biology, like the more like for tech people, the boring areas.
Yeah.
I think they give for really interesting use cases most of the time. How do you actually go on the reverse? How do you actually ensure that the queries you use or synthetically generate match up really well with the user queries?
And that's something where I think there is a lot more human intervention that is helpful than only relying on synthetic data. So I already mentioned the idea of few shot prompting, zero shot prompting. So I do think that it's highly valuable if you have a predefined list of questions that a human has written or something that you have gathered from a cold start use case, for example. You set something up in production without any evaluation in place. You collect the kind of questions that the users are interested in answering. You maybe map them to answers that human experts would label, and then use them as a few short prompting examples for an LLM. This, in my opinion, would be the best way to make sure that the LLM don't uh, diverge too far from what your idea of a good data set is. You, of course, also want to make sure that the LLM never escapes this conditioning logic that you give it. So it should always be constrained within the conditions that you give it, should be constrained within. Diversifying based on a dictionary of topics is a great way to make sure that LLMs only generate questions about a few topics that you're interested in. I know that essentially this would mean that you only have a few questions given a generic embedding model, for example, right? But it really does work. If you pick a multilingual dictionary, just like a normal dictionary with a lot of words, and you remove all the adjectives from this dictionary, you remove all the pronouns and prepositions from the dictionary, you do have a diverse list of topics, so to say, that an LLM could pick from, while still being constrained within the limits of what it should generate, and while still being constrained to following the same logic that you give it in the few shot prompting. So basically, the answer is few shot prompting is better than zero shot prompting in this case.
Yeah, we already ran through like a bunch of stuff, like for example, user personas, few short examples, example set of documents. What are other inputs that you've used for synthetic data generation? Also, like the topic dictionary.
Correct. Yeah.
What
So
else?
topic dictionary is one of them that we've used. There is, of course, this idea that you can incentivize an LLM with kind of incentives that you would give an intern, like I'll cut your salary in half or something like this. I don't have any like empirical results on whether this works or not. So I wouldn't be able to recommend one way or the other, to be very honest with you. These could be one. And the other kind of topics that you can give it is, of course, I don't know if you also discussed it, but tasks would be another topic. So a lot of the embedding models, especially nowadays, are instruction driven. So you do want to give it the instruction that the examples that you would generate based on this topic are going to be used to train a model for clustering, right? So make sure that your examples generate multiple examples that are clustered around the central topic of this, while being far enough from another topic that is Y. So you do want to give it an information of what the downstream task is going to be. It is also important, by the way, to not veer too wide and far, because there is this problem of being lost in the middle with a lot of LLMs. So you want it to be, want the instructions to be also be very precise. Try to make sure that the data that you generate is in structured format, and they should use it as well. Yeah, and that would be the extent of what you can give as an output to an LLM for synthetic data generation.
Yeah. And what is like the balance you actually strive for between synthetically generated data and real world data in your
Yeah.
evaluation dataset?
Yeah, that is a very interesting question, and one that I'm also trying to answer for myself. Again, I don't know if I have empirical results for this. Specifically, if you're talking about synthetic data for evaluation, I don't even know if there are many studies that show that you should have X% of synthetic data versus Y
Yeah.
percent of real world data. There have been some studies on this when it comes to actually training models. And depending on the task type that the models are being trained for, this ratio might also differ. There was this DeepMind paper this year or last year talking a lot about model performance as they improve or deteriorate with synthetic data generation. And they themselves showed that a lot of efficiency gain could be gotten from using synthetic data for tasks like improving your mathematical abilities, or not your mathematical abilities, but an LLM's mathematical abilities, improving the alignment of a multimodal LLM between like images and text, right? This is something that synthetic data can help a lot with. I had a look at these papers this morning and I still couldn't find any numbers about them, but I did see a lot of online discussion, and this kind of checks out with also our own experience of training embedding models internally, that a good split is somewhere between half and half. The half proportion of real world data makes sure that basically the quality of the model is beyond something that a like a non fine-tuned model can have. While if the synthetic data is far beyond half of a total volume of data that you're training with, then you stop getting these gains that I just talked about that are mentioned in the paper by Google DeepMind as well. So it seems like this the agreed consensus right now, unpublished in any academic source that I could find, is around half and half of synthetic data versus real data.
Yeah. And how do you actually go about like really methodically improving the data set? So you have your rack system basically in production.
Mhm.
How do you actually improve your evals as your system evolves as well?
And this is all about basically, once again, closing the circle on user intent. The best signal that you can get on these VAC systems, just like the best signal you could get on traditional search system, was to understand from the user if the answer was useful to them or not. And this is something that you have to continuously keep doing. Most of our users, our enterprise users who have seen the most success in their rack systems, are the ones that very early implemented continuous feedback mechanism. Having worked in an enterprise setting myself, having implemented such a system, I always have to also admit that this is not so easy to get feedback from the users directly. Most users don't want to spend any time on telling you whether this answer has been useful to them or not. So you, in addition to adding an active kind of a feedback loop, you also have to think about proxies that can tell you this. For example, oftentimes what we used to do is that we used to measure the time between two queries by the same user, right? Which would tell you whether with the first query, the answers that the users got were useful to them or not. Like it would at least indicate this was the case. Then there are obvious things like click-through rates of the top three results or the top 10 results or top one result, right? And if those click-through rates for the top K results are beyond a certain threshold, that is telling you that in most cases, the top results that you're showing the users are the ones that they are actually interested in. And again, none of what I've said, all three items, direct user feedback, proxy user feedback, or click-through rates, none of these are unique or novel in terms of what RAG has
Yeah.
put forward in place. This is basically classical search system implementation.
Yeah. What's next? So what's next for Gina? What's next for you? What's next for synthetic data? What's on the horizon that you're excited about?
I'm excited basically a lot more about our specialized models that are sub 500 million parameters, sub 300 million parameters. So base size models that are specialized for certain tasks. For your listeners who don't know, Gina is in the business of creating embedding models, general purpose embedding models, multilingual, bilingual so far. What we would continue to do, or what we would like to continue doing, is create embedding models that are easy to host on, let's say, a CPU, while being as performant as decoder-only embedding models of a billion parameter scale, right? Decoder-only embedding models, of course, great performance, but who has the capacity to host them even on a single GPU, right? We want to make these specialized models so good in terms of what their architecture is and what kind of specialized fine-tuning data set they've seen, that you simply can't look past them, that the latency is so good. So this is something that we're super interested in. I personally have also gotten more and more interested in the classification problem and why what is the appeal of boosted trees, for example, when it comes to classifying in the classical way, right? I have a hunch that the explainability of these traditional methods play a big role in why people like to use them for classification and not LLMs. And this is something that I think is a super interesting topic for deep learning scientists to also look into, improving explainability of their models, getting models, classification models. And I truly hope that if there is one message that your listeners and basically everyone building AI takes away, is that it's not that AI is a magic wand that can do things that you were not able to do before. That's not the right way to look at AI, but it's actually a way to, first of all, just like synthetic data, right? Increase the volume of the write operations, and it's really a way to think about how you can increase the efficiency of the processes that you already know how to accomplish, but then you replace the pure tedious and boring jobs that you have to keep repeating and instead use AI for it. That's where really the power is.
Yeah. And if people want to start building the stuff we just talked about, where would you point them? Like, where can they get started?
They should, of course, check our website. Gina.ai is our website. Our blogs are actually, in my opinion, a really good place to start for this as well. On our blogs, we put out articles that are not conditioned on any new developments that we're doing necessarily. And of course, there are release posts and so on, but there's a lot of opinion posts on our blog as well, which I truly think are not biased towards only what we are building. They're quite opinionated, as I think they should be. That would be a good place to get like some food for thought. In terms of building, for example, synthetic data sets, evaluating your systems, please check out also open source frameworks like Ragas. I'm really a big fan of these frameworks because they have a good, using open source framework is the only way to understand like what metrics are these frameworks measuring on your rack systems, not making them completely opaque. If the judge of your LLM is purely another LLM, then you also want to look deeper into why you should be doing that at all. Why shouldn't you have human annotated data? So I can highly recommend also using Ragas for evaluation. And yeah, if you're interested in fine tuning your own embedding models or seeing how synthetic data can improve models by fine tuning them on your domain, we also have a fine tuner tool on our website that basically uses synthetic data based on a domain and task description to fine tune either our own models or BGE's models.
Yeah. And if people want to follow along with you, where can they do that?
You can find me on X. My handle is Sahil, Saahil. I'm also on LinkedIn. I'm also on Fostodon, if you're on the Fediverse. And just follow me on GitHub. I sometimes commit there on our open source repositories as well.
So, what can we take away? I think, especially the point that RAG isn't a magic wand you can place on your product catalog or your data set and expect results you didn't get before is one of the most important parts. That embeddings, it bring a really good performance out of the box, but the performance is often capped, and it's capped at a point that it isn't good enough for most research applications. Once you bring them to the users, they might seem like they're working well, but in the end, often they truly aren't, especially because LLMs are really good at bullshitting and have a lot of internal knowledge. RAG systems often have the issue that you don't really know what's going on under the hood if you don't look at what is actually returned by your retrieval component. And often it's the case that even when you retrieve complete garbage, the model can make something useful out of it. And you basically have to first figure out, okay, there are some issues in your queries. What are the problematic queries? Why did it return these results? And how can you improve it? And there you then basically follow the system or the process he lined out. Basically, you first create a golden data set, which often consists of very common queries, but also basically the other frequencies of queries. If you haven't catched the previous episodes, you basically have 3 types of categories of queries based on the frequency, basically head, torso, and tail. And head queries are basically your most frequent queries, which you always want to have in your golden data set. And then you basically have torso and tail as well. And tail are like really specific queries, which occur very infrequently, but there is a massive amount of different queries in the tail. So you basically want to have a little bit from each category or each bucket of frequencies in your golden data set. And then you want to use that to test your retrieval system whenever you make a change. And this will actually show you, okay, you have your previous retrieval system, you take the golden data set, you run it against it, then you evaluate it. And for the evaluation, you can use a lot of different metrics. You can use precision, recall, MRR, you can use NDCG. And in most cases, you want a combination of these. But these, again, it depends a little bit on the application, especially where it's like more precision or recall heavy. And then you can, after a change to the retrieval system, you can run evaluations again and actually see whether you were able to improve it. And especially when you're adding completely new components. So, for example, you have an existing search database or you have a Postgres instance on which you're running your search just as full text search, and you want to add like a semantic search component, you can spin it and quickly run the evaluations. And when you don't really see any significant dent, it points you that it might not be worthwhile to even implement it. And then you basically go more into the direction that you want to systematically improve it over time. So you need to establish processes. So you want to actually monitor user behavior and how they react to the results or to the response. I think in traditional search application, that's a little bit easier because the results are given to the user, and then you can see based on the clicks and the dwell time whether the user actually was likely to have found the result relevant. Why I was talking like so unspecific, like was likely to have found, because you can never tell. It might have been like a clickbaity headline and the user just jumped into the video and then basically immediately went back. And this is also something you should probably track. So you can never be certain whether it was actually relevant. Or he might have clicked on the video and then just put his phone away but kept it running. So the video is high, the time is good, so the amount of time he spent on the video. But in the end, it doesn't really say anything because he didn't really watch it. So in the end, you have to look at those in aggregate. You have to use a combination of metrics so you can actually be certain that it is a positive or negative signal. And once you put these monitoring systems in place, you basically can improve the retrieval system. But with RAG, since you're generating an answer, it's a bit more complex because you're likely not showing the user all the results, but only the answer. So you have to figure out another way to basically propagate back to the retrieval results. So when you have an answer and if the user found it useful, like it gives you a thumbs up, you can likely say that the retrieval worked well. But in your retrieval, there might be 3 good results and 3 bad ones. The model just made something good out of it. So it's way more complex to actually drill down and get good feedback from the user with answer generation. So this is something that you probably have to think about a lot once you get into that place. And this is also something you will will likely have to do through some form of or semantic similarity, where you basically look at the chunks and see which chunks actually contributed to the answer it gave and which didn't, which are opposing to it or completely irrelevant, and then basically propagate back the feedback only to the chunks which were actually contributing to that specific answer. And yeah, I think it shows a lot of the complexity. And also, we always come back to the two different types of search, BM25 and semantic. And in most search applications, you're likely to use both. But I think this is also something he mentioned, then that if you get good results with BM25 and semantic search doesn't give you a significant better result, you should stick with BM25 because it's easier to have, it's easier to manage, and it's also way more computationally efficient. I think I've been babbling for a long time. One more point I want to mention is viewing synthetic data, that it's more important to actually constrain the generation to the system that's actually generating the data. I think this was really interesting, that you are always should try to restrict it into the bounds of the system. And the system probably is evolving over time as well, which means that your synthetic data generation should evolve as well. But yeah, this was the episode with Saahil. If you like it, let me know. Subscribe, like it. And if you're on Apple or Spotify, leave a review. It helps out a lot. Otherwise, we will be diving deeper into synthetic data next week. So stay tuned for that. Otherwise, have a good one and talk to you soon.